Hello everyone, my name is Jorge Isaac and my teammates are Daniel Lucero and Jose de Jesus. In this practice, we are going to implement an irrigation system with the FPGA in Quartus Prime Light. So let's start with the PhD.
So this is the BHDL code. This BHDL code is a part of our physical practice using a humidity sensor to control an irrigation system. The idea behind the design is simple. The FPGA reads the humidity signal and based on that input, it decides whether to turn the water pump or off, while also activating an indicator. At the beginning of the code, we import the IEEE STDG Logic 1164 library, which allows us to work with standard logic types such as 0 and 1. Then we define the entity called irrigation control. Inside the entity, we declare all external signals, uh, which are RST, which is the reset input, the humidity, which comes from the humidity sensor, the bomba, which is the output that controls the water pump, and indicator, which is another output used for visual signal like a LED. And inside the behavioral architecture, we describe how the circuit actually behaves. Here we have a process that is sensitive to RST and humidity, meaning that any change in those signals will trigger the logic inside the process. The logic is straightforward basically. Because first the system checks if the RST is 1. If reset is active, both the pump and the indicator are forced to 0, turning everything off. This is useful for initializing or stopping the system safely. And if the reset is not active, the FPGA then evaluates the humidity input. When humidity is 1, it means that the environment is dry, so the pump is activated and the indicator is turned on as well. When humidity is 0, it means there is enough moisture, so the pump and the indicator are turned off. So overall, this module automates the irrigation process. When moisture is low, it turns on, and when moisture is fine, it turns off. The process structure ensures a reliable and immediate response whenever the inputs change. And that is basically how this BHDL model uses the sensor data to handle irrigation controls on the FPGA board. And that's all for this explanation.
So here we are on the VHD. So this is used to verify the functionality of the irrigation control system before programming on the FPGA. So in this test bench, we instate the irrigation control module and generate different combinations of the result and humidity signals to observe how the pump output reacts. The sequence applies low and high levels to the humidity input while toggling the reset signal, allowing us to confirm that the pump actives only when humidity is high and reset is inactive. The simulation also checks when reset is 1, the pump stays off regardless of the humidity level. This ensures safe behavior. Overall, the PhD allows us to validate the logic in a controlled environment and provide correct output transitions before moving to hardware. So here you can see this is what we do. And for upload to the FPGA, we click on Programmer here, and we click on the button that appears here and in Start, and wait until it's 100% uploaded. So let's see how it works in the FPGA.
Okay, so this is the irrigation control. Has the amplifier, which is we're measuring the output, and we'll have here the motor, which is going to be watering the sensor. And let's just see how this works. Okay, so whenever I do this, this in this moment should be starting to, well, as you can see, just a little bit more time. Just okay, so as you can see, whenever I will take up this the sensor, it's going to start watering. Okay, so I'm just gonna place it, and as you can see, it has already been working. Whenever it takes the water, the sensor is already watered up, it will stop watering, it will stop the motor, and won't be watering anymore. Just this dirt actually. So that's kind of all of it, as you can see.